Hi, everyone. So we got a couple more minutes, but then we'll get started. So in the meantime, I'm going to share my screen with everyone. Get the slides up and running here. All right. Yes, lovely weather. Who likes the rain? I like the rain. In fact, it was really, really pouring. I mean, I know some of you are joining us from outside of Ottawa, um, but if you're in Ottawa, nice thunderstorm this morning. Yeah, the tornado watch or warning or whatever it was. Yeah, hopefully nothing happens there. Um, it's funny, I was watching the birds at my bird feeder. They show up whether it's raining or rain or shine. And this morning they were all wet um, as they were feeding. It was kind of funny, but I hope they're okay. Now, so it's time, like, I guess we'll get started. Yeah, it's 2:35 now. We might as well get started. One real quick thing, before I do that, is that the quizzes, quiz number one, Karanvir and I have finished marking those. Those grades should now be available to you. So I'm not exactly sure how this looks on the student side of Brightspace, but there is a way where you can view your grade and whatever feedback comments we've given you. So definitely do that. I have to say I was impressed with the performance of everyone on the first quiz. The class average was pretty good. So good job to all of you. Um, we'll have the second quiz graded in short order. It shouldn't take as long as the first quiz did because, again, I got sick last weekend and it's kind of taken me a while to shake it. I don't know what it was. Um, some kind of awful cold or flu or something. But yeah, it took a while to shake that. So I was a little slow getting to things. But now that I'm recovered, should be able to get through the other quizzes, that is quiz number two, quickly. So, the topic for today is mind as the brain. That is the psychoneural identity theory, the theory on which we identify mental states with brain states. This is a long chapter, and I have cut some of it out for today, particularly as we get towards the end. Um, when we look at some of the considerations against type identity theory, we'll mostly be looking at um, like functionalism stuff, the multiple realizability objection. But we're going to try and get through most of the other stuff in the chapter. And here I have a brain in a vat, if you like. This is a human brain that I believe was taken from a cadaver. And the human brain is pretty cool. The human brain it is estimated probably about 86 billion neurons. And of course, neurons are connected to one another, not directly, but connected effectively via synapses. So brains have these nerve cells called neurons. We have 86 billion of those. And those neurons, via their axons and dendrites, connect with other neurons and communicate with one another in this sort of electrochemical way. We don't need to get bogged down into the details. But the point is that, where we have billions and billions of neurons, we have trillions of connections between neurons. And all of this is to say that the human brain is probably one of the most complex things in the known universe. And we're all walking around with one in our head, which is kind of neat. And today we're used to thinking about the brain as the basis of the mind, right? But this was, of course, not always the case. Back in the day, in ancient Egypt, for example, they didn't know what the brain was for. When Egyptians mummified their dead, they would preserve the organs in these canoptic jars because the idea was that you would need all of your stuff in the afterlife, right? You would need, for example, your earthly possessions. And that's why pharaohs were always buried with all kinds of treasure and chariots and all kinds of stuff. The idea was they would need all of that in the afterlife. They were buried with all of their organs because they're going to need those: the lungs, the heart, the liver, all of the important organs, but not the brain. The Egyptians didn't know what the brain was for. They would, in fact, remove the brain basically with this sort of copper tool that would go up through the nose. And this is a little disgusting, but would go up through the nose, scramble the brains around, and pull them out. And then they would just discard them because they had no idea what it was for. Likewise, the ancient Greeks. And by the way, we talk about the ancient Egyptians and the ancient Greeks like they're both ancient, but Egypt was ancient to the ancient Greeks. That's how ancient Egypt is. So the Greeks, even though they were arguably a bit more advanced than the ancient Egyptians, they still didn't know what the brain was for. In Aristotle's treatise on the soul, De Anima is his Latin title. He speculates that the brain is like maybe a kind of cooling system. He doesn't associate it with thought. In fact, he explicitly says that all of our senses are each associated with an organ, but thought is not associated with any organ, which is kind of weird if you think about, compare it to our perspective today when we have a pretty good understanding of the brain's role in perception and cognition. And for that matter, depending on the culture that you're talking about, it was usually either the heart or the gut that was associated with thinking and feeling. In Western culture, it tends to be the heart, but also the gut. We talk about, there's that expression, I know something off by heart, right? Which means you've memorized it. But of course, you use your brain for that, not your heart. Sometimes the heart or the gut are associated with one's conscience, right? In feudal Japan, this is one of my favorite little historical factoids. In feudal Japan, the gut, they talk about the gut the way that we in the West might talk about the heart. So if, for example, you wanted to describe somebody as caring and generous, we would say that maybe they have a big heart. But in Japan, in feudal Japan, they would emphasize the belly. And this is incidentally why when samurai would commit ritual suicide, they would spill their guts rather than stabbing themselves in the heart or something like that, right? So a little morbid, a little gross, but yeah, it just speaks to our association of thought and feeling with parts of the body other than the brain over the millennia. So of course now we associate the mind with the brain, but is your mind just your brain? Yeah, exactly. Jill says in the chat, we say things like I feel it in my gut, right? In the viscera. And Plato, incidentally, when he divides the soul into three parts and he associates the appetitive part of the soul with the gut, the spirited, the part that governs the passions or what we'd call emotions, with the heart, and the intellect with the head, but not specifically the brain, which is weird, right? But yeah, we still have this way of talking. We say somebody is kind-hearted, big-hearted, or I have a gut reaction to something, or you don't have the guts for something, right? To imply that somebody is perhaps a coward. We say they don't have the guts, right? It's one of my favorite characters from that show, Battlestar Galactica. Colonel Ty. He's always talking about how you don't have the guts. He's just known for it. Yeah, trust your gut. Sohila, that's another good one. Yeah, so our language still preserves this. But of course, we know that cognition and perception depend on the brain and the central nervous system. But is your mind just your brain, right? We've known for a long time that changes in the brain correlate with changes in the mind. So we know this, for example, because of brain injuries. I've mentioned Phineas Gage in this class before. Phineas Gage was the railway foreman who had the tamping iron blown through his skull, and it caused injuries to his prefrontal cortex, which resulted in changes in personality. And you know, in the early, late 19th century and early 20th century, when neuroscience was starting to emerge as a science, a lot of information was gleaned from injuries that soldiers acquired. For example, soldiers might be shot in the head and survive. And this is how some of the earliest brain mapping was done. Scientists and physicians would look at what parts of the brains were damaged and then the subsequent effect that that would have on behavior. And it's an unfortunate consequence of, military conflicts in the late 19th century, and then especially World War One in the early 20th century. Um, well, an unfortunate consequence that so many people were killed and injured. But perhaps the silver lining is that we were able to learn a lot about what areas of the brain are responsible for which cognitive functions. Um, and of course, you also have the earlier work of guys like Paul Broca, too, who looked at people who had strokes and stuff, like other kinds of acquired brain injuries, right? So we know that brain injuries can change behavior, they can change thought and perception in very specific ways, depending on what part of the brain is injured. There are, of course, mind-altering drugs. When there's a change in the chemistry of the brain, that will cause perhaps an altered state of consciousness, we could call it, right? And again, something I've mentioned in this course is that the reason this works is because psychoactive substances are always chemically similar to endogenous neurotransmitters. That is, neurotransmitters that are found naturally in the brain and central nervous system. So to take some more everyday examples, right? If you have a substance like cannabis, that affects the mind because within our body we have these endogenous cannabinoids, natural chemicals that are molecularly very similar to things like THC. And that's why THC has an effect upon us because it fits into these little receptor sites that the endogenous cannabinoids work on. Alcohol is a very widely consumed substance, and it has a sort of inhibitory effect. There's an inhibitory neurotransmitter called GABA, gamma aminobutyric acid, and it's an inhibitory neurotransmitter. It has the effect of slowing down the communication between neurons. Alcohol works on these receptors, which is why alcohol is a depressant. Doesn't necessarily make you depressed, it depresses activity in your central nervous system. But let's not forget about the most widely consumed drug ever, caffeine, which I love. I don't have a problem. I can quit whenever I want, but I just need one more sip. So caffeine is a stimulant, which means it works on your dopamine receptors, like other stimulants do. So dopamine is involved in the pleasure reward system. It's involved in all kinds of things, everything from modulating our attention, executive control, all the way to feeling good when you accomplish a task or when you eat something delicious, or when you beat that video game that you've been struggling to beat, or when you finish that essay and you get an A+ on it. Dopamine, that's what makes you feel good. So caffeine works on our dopamine receptors. Well, caffeine, I mean, you can get addicted to caffeine. It's certainly not as It's not as bad as right. I wanted to make a point of making sure I read the chat, read the questions in the chat out loud, because it was brought to my attention that you guys can't see what I see in the chat. But Sohyla says it doesn't stimulate addiction. You can certainly get addicted to caffeine, but it's not as dangerous for you as other kinds of addiction, like alcohol addiction. Like if you are a heavy caffeine drinker like I am, and you go a few days without caffeine, maybe you'll have a headache and be a little grumpy, but you're not going to die, right? Alcohol withdrawal, oh yeah, caffeine does. It definitely does. But alcohol withdrawal can kill you. Um, and so and by the way, I am oversimplifying a little bit, like you know, certain drugs uh certain drugs mimic the behavior of endogenous neurotransmitters. Some mimic neuromodulators, so some are agonists and some are antagonists, receptor agonists and receptor antagonists, right? Sometimes they block, if they're an antagonist, they block an endogenous neurotransmitter from doing its job. If it's an agonist, it acts like that neurotransmitter. Um, yeah, yeah, Thomas, that's a good point, right? Like, you can get addicted to video games, right? People are addicted to pornography, right? Um, and that's also hijacking the pleasure reward system, but that's not because it's got some chemical effect itself, right? In the brain. So that's a good thing to point out. But for those substances that we do put in the body that alter our consciousness, they work on a chemical basis. Anesthesia is another interesting example that Kim mentions. Anesthesia blocks certain signals from going into the brain or out of the brain. So, and thank goodness for anesthesia, that's how we can do um, surgeries and stuff. Humans have actually been performing surgeries for a long time, but we have not always had anesthesia. So imagine what that would have been like, having to undergo surgery pre-anesthesia. Um, Ouch. That's all I'll say about that. More coffee. So, all of these kind of give us reasons to think that the brain is the basis of the mind. Kim articulates it thusly. He says, it is plausible that everything that occurs in mental life has a state of the brain or the central nervous system as its proximate physical basis. So, that brings us to the mind-brain correlation thesis. For each type M of mental event that occurs to organism O, there exists a brain state of kind B, that's M's neural correlate or substrate, such that M occurs to O at time t if and only if B occurs to O at time t. Now, this is another one of those schematizations or formalizations that Kim is so fond of doing. What is he saying here? I realize that often I just jump straight into explaining these little theses and principles to you, but I wonder if somebody would like to take a stab at putting this in plain language. Anyone want to put the mind-brain correlation thesis in plain language for us? And you can use the chat, or Jack, go ahead.
Yeah, he's basically just saying that if there's some kind of like event like pain that happens, it's because there's some brain state that's bringing about that pain, and in that way the mental state is identical to that brain state, I
Yeah,
guess.
we haven't gotten to the identity claim yet, but that is where we're going to end up. But for now, yes, these are neural correlates. We call them neural correlates. So, and the shop worn example is pain and your C fibers firing. C fibers are a type of nerve cell that fire when we're in pain. Um, so my subjective experience of pain, my mental event, M, which is pain, that occurs to me at a certain time, only occurs to me if the brain state also occurs. My C fibers are firing. So these are so far we're only talking about correlations, and these correlations are law-like, right? We experience pain when some of our neurons, like our C fibers and our A delta fibers, are activated, and this is a law-like regular occurrence. It's not an accident. It's not a coincidence. Um, it seems to be the case, barring weird medical cases, that when one's C fibers or A delta fibers fire, one is also in pain, and they're law-like because it usually happens that way. Well, Michael asks if is there even a difference between a mental event and a brain event, and some would say yes. Um, Reductionists would say no. Identity theorists would say no, right? And that's where we're going to end up. Identity theorists, oh, event versus state. Sorry, I misunderstood. Not really. I mean, I would say keep those terms. We can more or less use them interchangeably here. Um, yeah, I would say we can think of those as interchangeable. Um, okay, so these are law-like regular co-occurrences. And another thing we can say about these correlations is that even the smallest change in our mental life won't occur unless there's a change which we might not know about yet in a brain state. If your headache goes away, right, there must be an appropriate change in the neural substrates, the neural state. So if I have a headache, I'm in a state of pain, I take some aspirin, that changes the chemistry of my brain or my central nervous system or both, and I stop experiencing pain. So any change in my mental state, any new mental event must co-occur with the right sort of change in my neural states. Now we're talking about correlation here. An important thing to keep in mind is that correlation does not always mean causation. I mean, that's something we're all kind of cautioned against, especially if we've ever taken a statistics class. We're cautioned against assuming that because something correlates with another thing, that there's a causal relation. Oftentimes there is a causal relation, but that doesn't mean we can just work out what that causal relation is simply by identifying a correlation. Who's got some examples? Correlation not equaling causation. I have a couple classic ones that I like to bring up. For example, you can Google this one. It's quite funny, but apparently the rates of drowning in pools in the United States corresponds to the box office performance of Nicolas Cage movies. This is a complete coincidence. Nicolas Cage is not causing people to drown in pools, right? So correlation does not equal causation, right? Ice cream sales do not cause crime. Summer does. Yeah, Thomas, that's a good one. Like in the summer, the weather's nicer, so you can go out and do more crimes. But people also eat more ice cream in the summer. But of course, ice cream doesn't cause the crimes. Yeah, watching TV and having a headache. I suppose for some people, though, it depends what you're watching. Bright lights can cause a headache in some folks. But yeah, is this a thing though? Like, Nermith, if Is that a thing that people report? Oh, your parent. Okay. So your parents say that. Yeah. Well, that's funny because when I was young, my parents would always say, don't sit too close to the television because it'll be bad for your eyesight and you'll need glasses. And of course, I wound up with glasses. But is that because the television caused my poor eyesight? No. Probably I was sitting closer to the television because my eyesight was already starting to go. Well, I mean, not go, but like to be less than 20/20. So that's why I was sitting closer to the television, right? Um, any other examples? In the UK, Michael says in the UK years ago, there was mad cow infection. The cell device deteriorated to failure. The cell service deteriorated. Turns out maintenance crews were not allowed into the areas, and the system slowly failed due to lack of maintenance. Oh, okay. That's an interesting relationship. That's a kind of indirect causation, I would say. I remember that. What was that? That was mid 90s. I wasn't in the UK, I was here. Um, but I remember that being a bit of news that often came up at the dinner table or in class. It was the mad cow thing. Well, good examples, everybody. Let's turn to some other kinds of correlation. Um, where we do have some causes. We have some cases of cause of correlation being explained by causation here, but also some cases of correlation being explained away as cases of identity. So as we go through all of these, keep in mind the case of the mind and the brain. So the first one, whenever the ambient temperature falls below 20 degrees Fahrenheit and stays there for several days, the local lakes and ponds freeze over. Why? The answer, of course, is that the low temperature causes the water in the ponds to freeze. The two events are causally related, and that is why the observed correlation occurs. This one's very straightforward, right? When water drops below 0 degrees Celsius, it forms crystals, ice crystals. Water becomes a solid. So when the temperature drops, I guess 20 degrees Fahrenheit. Fahrenheit is so weird. Everybody should use Celsius. It's so much easier. But anyway, 20 degrees Fahrenheit, 0 degrees C. That is a causal relation between temperature and the state of matter that the water in the ponds is in. Here's another one. You enter a clock shop and find an astounding scene. Dozens and dozens of clocks of all shapes and sizes are busily ticking away, and they all show exactly the same time, 2 o'clock. A while later, you see all of them showing exactly 2:30, and so on. What explains this marvelous correlation among these clocks? Here, a common cause, the shopkeeper's action in the morning, explains the correlations that are now observed. To put it another way, one clock is showing 3:30 and another showing the same time are collateral effects of a common cause. So here we have one cause, the shopkeeper, which we'll call A, and numerous effects, say B through Z. Say he has, 25 clocks. Um, so all of the effects, the time displayed on the face of each clock are the result of a common cause, namely the shopkeeper and his actions when he opens up the shop in the morning. Here's another one. We could imagine a slightly different explanation of why the clocks are keeping the same time. These clocks actually are not very accurate, and some of them gain or lose time markedly every 5 minutes or so. But there's a little leprechaun whose job is to run around the shop unseen by the customers, synchronizing the clocks every minute. This explanation involves the continued intervention of a causal agent. So, unlike the shopkeeper who synchronizes the clocks once in the morning, this leprechaun goes around synchronizing the clocks, every minute. So this involves the continued intervention of a causal agent, a common cause. Um, uh, whereas in the first example, a single past cause is sufficient. In each of these cases, though, as Kim says here, there is a direct cause-effect relation between the correlated events. Either this continuous causal intervention of the leprechaun in the case of C, or in B, the intervention of the shopkeeper in the morning. So everybody's following along so far, right? We've just got a couple more to go. Here's a sciencey one, or a couple sciencey ones. Why do temperature and pressure covary for gases confined in a rigid container? The temperature and pressure of a gas are both dependent on the molecules or the motions of the molecules that compose the gas. The temperature is the average kinetic energy of the molecules, and the pressure is the momentum imparted to the walls of the container per unit area by the molecules colliding with them. Thus, the rise in temperature and the rise in pressure can be viewed as two aspects of one and the same underlying microprocess. This is governed, by the way, by the gas law. Well, so good question. So Hyla's asking, how is this related to mind-brain correlation? Well, all of these are different ways of understanding causality when we observe two or more things that are correlated. And we want to work out which kind of causality we're dealing with, or whether we're dealing with nothing at all, and we just want to identify brain states with mental states. So that's why we have to keep in mind the mind-brain correlation as we run through these examples. So again, the gas law, which you can ask your physics professor about, defines how gas behaves under pressure. More pressure affects the temperature of the gas. But pressure and temperature are both aspects of this one underlying microprocess, right? The motions of the molecules that compose the gas. And E, why does lightning occur just when there is an electric discharge between clouds or between clouds and the ground? Because lightning simply is an electric discharge involving clouds and the ground. There is here only one phenomenon, not two that are correlated with each other. And what we thought were distinct correlated phenomena turn out to be one and the same event under two different descriptions. Here, an apparent correlation turns out to be an identity. And this is kind of where the identity theorists are going with this, right? The mind just is the brain, just as lightning just is an electrical discharge in the atmosphere. It's not like lightning supervenes on electrical discharge in the atmosphere. It just is the electrical discharge in the atmosphere. And identity theorists and reductionists will say that, well, beliefs and desires just are mental states. Another one. Why do the phases of the moon, full, quarter, half, so on, covary with the tidal actions of the ocean, spring tides, neap tides, and so on? Because the relative positions of the Earth, the Moon, and the Sun determine both the phases of the Moon and the combined strength of the gravitational forces of attraction exerted on the ocean water by the Moon and the Sun. So the changes in gravitational force are the proximate causes of tidal actions, and the relative positions of the three bodies can be thought of as their distal cause. The phases of the moon are merely collateral effects of the positions of the three bodies involved and serve only as an indication of what the positions are. Full moon when the Earth is between the sun and the moon on a straight line, and so on, having no causal role whatever in tidal actions. So, in this case, it's where the sun, the moon, and the Earth are that determines the strength of the tides, as well as what phase the moon is going to be in. People may see the moon in a certain phase or another and think that that causes the tides to be stronger or weaker or to occur at different times. But no, really, both the strength of the tides and the phase of the moon are a consequence of how these bodies are moving relative to one another. right? So to try and bring all of these examples to bear on mind-brain correlations, we've seen we've seen a few examples that we might be able to map on to some of these ideas, right? Causal interactionism. Here we're talking about something like Descartes' substance dualism, where we have two substances interacting with one another, where physical events like those that happen to our sense organs can affect the mental and cause perceptions, or intentions, mental events can cause actions, right? There's a causal interaction going on there. Or we could think of pre-established harmony, Leibniz and his monads, if you like. The pre-established harmony. Think of the clock shopkeeper who synchronizes all of the clocks every morning. That's like a pre-established harmony. What about occasionalism? There was another rationalist, an early modern rationalist thinker, Malebranche, who advocated for occasionalism. And this is an interesting one. Who knows about occasionalism? And who would like to take a crack at giving a description to the class? Well, occasionalism has it that only God is a causal agent. It's not quite like Leibniz, where God sets everything up in a sort of pre-established harmony. So there's no interaction, right? On pre-established harmony, if you imagine like a, a sort of pool table billiard ball causation scenario, um, an interactionist would say, well, I move the cue stick, which strikes the cue ball, which strikes the 8 ball, which rolls into the corner pocket, right? A causes B, causes C, causes D. Leibniz would say, no, the cue stick, the movement of the cue ball, the movement of the 8 ball, all of this was pre-established by God. So it only appears as though there's causal interaction. Yeah, Jack says that Kim explains this nicely in the textbook. It is weird. It is I think it is an odd way to think about causation, but unlike pre-established harmony, occasionalism has it that um, God is the only being that can cause anything. So if I, say decide I'm going to put my hand up, and this is following Kim's example. I decide I'm going to put my hand up and then I raise my hand. I didn't actually raise my hand. Rather, I formed the intention to raise my hand, and then God raises my hand. He causally intervenes, raising my hand. And that is occasionalism. It, it's strange. It's strange, but it is one way to think about these causal correlations. Double aspect theory, or sometimes dual aspect theory. Here you might think of Spinoza, who said that he was a substance monist, right? He said that Descartes got it wrong when he said that mind is thinking substance and bodies are extended substance and they somehow interact. No, 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 no. There's only one substance, God or nature. And we're all just finite modes of that substance. And we have different attributes. We have the attribute of thought and of extension. So there's no interaction problem because there isn't two substances. There's only one substance. There's a sort of modern, the modern kind of version of this um, is called neutral monism, where unlike dualism, which says there's physical substance and thinking substance, or physicalism, which is a kind of monism that says there's only physical stuff. Neutral monism says that there's stuff, there's only one kind of stuff, but it's not strictly physical nor mental. It's kind of both at the same time. So that's neutral monism. You also have epiphenomenalism, which is advocated famously by Thomas Henry Huxley. Darwin's bulldog, he was known as. He was a 19th century naturalist. who was a vigorous defender of Charles Darwin's theory of natural selection. And Huxley believed that physical events can cause mental events, but mental events cannot cause physical events. Huxley, incidentally, called us conscious automata. We are living machines with minds. So, the way I like to characterize epiphenomenalism is that when it comes to mental events, mental states, it's all effect and no cause. So brain states can cause mental events, but my mental events are not what cause other physical events. Huxley likens it to the whistle on a steam engine. The steam engine can affect the whistle. The excess steam can be redirected from, turning a turbine or a gear or whatever it's doing to blowing the whistle. But blowing the whistle doesn't do anything to the engine. Everybody following so far? All right. There's also emergentism. Here, correlations between mental and physical are simply what we call brute facts. It's as simple as we can get. The mental just emerges from physical processes of sufficient complexity. I mean, who knows? Like, this is a bit weird when you first try and think about it, when you apply it to consciousness and other kinds of mental states, because emergentism is a bit of a kind of a tricky concept to get your head around. But maybe we can think of um, some example of an emergent phenomenon. Who would like to take a guess? Remember, when we're talking about an emergent phenomenon, we're talking about complexity arising out of simplicity. Actually, I don't really like the way that Kim characterizes emergentism. He says that something like, mental events emerge from the complexity of physical processes. No, it's the complexity that emerges out of simpler physical processes. That's actually, I think, a better way to characterize it. But who knows an emergent phenomenon? Who would like to name an emergent phenomenon? So in the chat, we have one. Food chains. Um, Sort of. I mean, I suppose that's not really what I have in mind, although some food chains are quite complicated. Traffic jams, maybe. Venance, go ahead.
I don't know if this is accurate, but for me, I would say like a clock is the complex system, and then out of it comes a simpler phenomena, time. The complexity.
Um, not quite. That's a good guess, but not exactly.
Okay.
Um, so okay, here's a good example. Who knows what murmuration is? So murmuration is a phenomenon that you've probably seen if you've seen really big flocks of birds flying. Yeah, exactly, Deborah. Bird flocking. You know how all those birds, it's like there could be thousands of them, and they seem to just move at once, at one, right? As if they're one entity. That's an emergent phenomenon. It emerges out of simplicity. Each bird only has to do two or three simple things, right? These murmurations look so beautiful and complex that some have even put forward pseudo-scientific theories to explain the flocking behavior. As if the birds are all telepathically in sync with one another or something, right? But we don't need telepathy or anything like that to explain murmurations. No, the birds are all just following two or three simple words. Two or three simple words, keep so far away from the birds that are next to you, head in the same directions as the birds that are next to you. If you see food, go towards the food. And if all these birds are just following these simple rules, what we get is this incredibly complex flocking behavior. That's an emergent phenomenon. Speaking of clocks, another one is called another emergent phenomenon is called synchronous oscillation. If you put a bunch of clocks on a wall or metronomes on a table and you set them all going differently, because of the way that as they tick, the vibrations go through the wall or the table and affect the clocks that are next to them, they will all synchronize without you having to do anything, just because they're all affecting one another by virtue of their vibrations that they're sending out through the wall, and that affect the motions of the mechanisms of the other clocks or the other metronomes. So that's synchronous oscillation. That's an emergent phenomenon. Yeah, crowd behavior in concerts. Yeah, could be another one. Sometimes people just start doing what the people next to them are doing. And then you get complicated forms of behavior in the crowd, like everybody's doing the wave, or if you go to you ever been in the mosh pit in like a metal concert, people will be chaotically bouncing off of one another, but then all of a sudden maybe they're all spinning around in a big sort of spiral or something, right? We're almost doing our own version of bird flocking when we're at concerts. And fish schooling too is another example of this, right? So those are all very good examples of emergent phenomena. The psychoneural identity theory does what we did with lightning, right? Lightning just is electrical discharge in the atmosphere. The mental just is the brain and its states. Mental events are just brain events. And it's as simple as that. And we call this identity theory, the psychoneural identity theory. The mind is the brain. Mental states are physical states, namely brain states. And this was famously advocated for by J.J.C. Smart, an analytic philosopher who offers this argument from simplicity. And this is quoted in Kim, and I'm going to read Smart's passage to you. It's in its entirety here. Why do I wish to identify sensations with brain processes? Smart asks. Mainly because of Occam's razor. There does seem to be, so far as science is concerned, nothing in the world but increasingly complex arrangements of physical constituents. So this is pretty thoroughgoing physicalism here. All except for one place, in consciousness. That is, for a full description of what is going on in a man, you would have to mention not only the physical processes in his tissues, glands, nervous system, and so forth, but also his states of consciousness, his visual, auditory, and tactile sensations, his aches and pains. That these should be correlated with brain processes does not help. For to say that they are correlated is to say that they are something over and above. So sensations, states of consciousness, do seem to be the one sort of thing left outside of the physicalist picture. And for various reasons, I just cannot believe that this can be so. That everything be explicable in terms of physics, except the occurrence of sensations, seems to me, frankly, unbelievable. So what is Smart saying there? Anybody want to try and put this in their own words? If not, I will go ahead and do that. But somebody take a stab at it. Somebody maybe we haven't heard from yet. All right. Well, what Smart is saying is that in every other place we look, everything seems to be just physical. Everything has a physical cause, a physical explanation, right? This is a principle we call the causal closure of the physical domain. What that means is that any physical event that happens has a sufficient physical cause. It's not as strong as determinism. It's not saying that every event necessarily has a physical cause, but it's saying that we don't need to bring in any non-physical causes to explain anything physical. And it's an important limiting principle of naturalism, which is the outlook that we are adopting in this class, the outlook that natural philosophers and scientists adopt when trying to understand the world. So if you're going to be a naturalist, if you're going to be a physicalist, and everything has a physical explanation, then you might want to get rid of mentalistic talk, or at least identify the mental with the physical, because there shouldn't be anything over and above the physical. Lightning, there's no lightning over and above electrical discharge in the atmosphere. Why do we want to do this? Because of Occam's razor, which is it's another name for the principle of parsimony, which is another important principle in naturalism. There's a couple ways that we can understand Occam's razor. One formulation that you often see is number one, entities must not be multiplied beyond necessity. And the other is that what can be done with fewer assumptions should not be done with more assumptions. So the first formulation we can call the ontological formulation. We don't posit entities or beings that don't do any explanatory work for us. So think, for example, back to the clock shopkeeper examples. So you walk into the clock and you walk into the shop and all of the clocks are synchronized. What's the simpler explanation? That the shopkeeper synchronized them once all that morning, or that every minute on the minute, an invisible leprechaun comes out and synchronizes all of the clocks? Well, the simplest explanation rather, is that the clock shopkeeper synchronizes the clocks every morning. Our invisible clock altering leprechaun doesn't do any explanatory work that the first explanation can't do. So we don't need to posit the invisible clock leprechaun, right? Formulation 2, the principle of parsimony. Use the fewest unwarranted assumptions as possible. Again, why make the assumption that we have this timekeeping leprechaun? We don't need to make that assumption. What other examples can you think of either formulation of of Occam's razor? You can pick either the ontological formulation or the parsimony formulation. But let's have some examples. Jack, go ahead.
Probably one that you might be a little bit partial to, I guess, like ghosts or other supernatural encounters, perhaps.
Yeah, totally. In fact, in my philosophy of the paranormal class, I spend a good bit of time on Occam's razor, and of course, Occam's razor is an incredibly useful tool if you want to bust pseudoscience. So let us say that somebody claims that their house is haunted. That is, that it's inhabited by a ghost, like a poltergeist. A poltergeist, that comes from the German. It means noisy ghost. So a poltergeist is supposedly a spirit that makes noises, throws things off of shelves and so forth, right? The kind of thing you might see in a movie like Poltergeist or Paranormal Activity or something like that, right? So you experience these odd events in your domicile and you attribute them to a ghost, when perhaps there's a simpler explanation, like you live in an old house. There are animals living in the attic. There are places where the draft enters the house and moves the curtains, even though the window appears to be closed, right? Or when it comes to psychic mediums, what is the simplest explanation for what psychic mediums do? Is it that they have psychic powers and they can communicate with the dead? Well, no. The simplest example is that they are probably either cold reading or hot reading, whether they realize it or not. So in both of those cases, we're kind of applying both versions of this principle. We're not positing entities that don't do any explanatory work, like spirits or ghosts. And we're using the fewest unwarranted assumptions, like the assumption that there are those with psi abilities, even though there's not any good evidence for such abilities, right? Those are good examples, Jack. Thanks for bringing those up. So is everybody clear on Occam's razor? It's an important thing to know. It's an important, as I said, it's an important principle of naturalism. And naturalism is the view that everything that exists is natural, is part of the physical universe, right? And there are different ways you can look at it. There's like metaphysical or ontological naturalism, which says that, you know, that the only stuff that exists is natural stuff. There's no supernatural stuff, no gods, no spirits, nothing. And then there's or methodological naturalism, which is not quite as strong. Methodological naturalism is what a scientist does. You know, they don't, a methodological naturalist might say, well, sure, there might be ghosts or maybe there's a god, but scientists just doesn't look into that stuff. So that's the difference. So how does Smart's argument fare that we need to apply Occam's razor when it comes to mentalistic talk and simply identify mental events and mental states with brain events and brain estates? If we apply Occam's razor and follow Smart, it certainly seems to simplify our ontology, right? Why, you know, if we want to avoid multiplying entities beyond necessity, well, you know, it's like we have two terms for the same thing. You know, we belief and desire on one hand, you know, the mentalistic terms, pain. And on the other, we have physical explanations, you know, neurons firing in such and such a way. Let's just get rid of this, get rid of the mental talk and simplify our ontology by identifying anything mental with what is physical. Seems fine, seems to simplify things, right? It also seems conducive to kind of like a logical or linguistic simplicity, right? I mean, a lot of these folks who want to identify the mental with the physical or dispense with mentalistic talk altogether, they are aiming for simplicity, in line with the principle of parsimony. What Smart seems to have in mind here, Kim says, is this. Suppose we stop short of identifying pain with C fiber stimulation and stick with the correlation. Pain occurs if and only if C fiber stimulation occurs. Well, now we have a problem. How do we explain these correlations? In science, what we do is we explain laws and correlations by deriving them from more fundamental laws and correlations. So are there more fundamental correlations from which we can derive something like pain occurs if and only if C fiber stimulation occurs? What do you think? Jack, go ahead.
I think the route that the identity theorists take is really cool, where they just claim it's identical, and then you don't actually have to explain any of these correlations that are happening, or you don't have to appeal to anything kind of more fundamental going on.
Yeah, well, that's what they see, I think, as the virtue of their approach. But Kim, of course, has a bit of an issue with it because it's like you are by doing that, are you explaining or are you explaining away, right? And the difference is, you know, when you're explaining one phenomenon, if you're properly explaining it, you're explaining it in terms of more fundamental laws. But if you're explaining something away, you're just kind of getting rid of it. Is there a more fundamental correlation from which we can derive pain occurs if C fibers firing occurs? Well, the identity theorist would say no, and that's a good thing. But yeah, they would say what Michael says, pain just is C fibers firing. There's nothing more fundamental than that. But is that a good explanation? Here, here Kim says something interesting on page 101. Compare this bloated picture with what we get if we move from psychoneural correlations to psychoneural identities. From pain occurs just in case C fiber stimulation occurs to pain just is C fiber stimulation. Pain and C fiber stimulation are one and not two, and we are not faced by two distinct phenomena whose correlations need to be explained. In this way, psychoneural identities permit us to transcend and renounce these would-be correlation laws, what Herbert Feigl aptly called nomological danglers. I like this, nomological danglers. Nomological pertains to law-like relations, from nomos, which means law in ancient Greece, and logos. So pain occurs just in case C fiber stimulation occurs. Well, it'd be simpler just to say pain equals C fiber stimulation. But here's something to consider. If we opt for the psychoneural identity route rather than the psychoneural correlation route, well, doesn't the psychoneural identity theory merely replace psychoneural correlations with an equal number of psychoneural identities, one for one? Here's where I kind of skipped over the messy bit here, but what Kim tries to do prior to this passage that I quote on 101 is try and work out a number of psychoneural correlations that can explain why pain occurs just in case C fiber stimulation occurs. And we can go on ad infinitum. Now, an identity theorist is trying to simplify things, but by merely replacing the correlations with identities, are things really getting simpler? So Smart's argument from simplicity appeals to the simplicity of identity statements over correlations, right? Pain just is C fiber stimulation is simpler than pain occurs if and only if C fiber stimulation occurs. But it doesn't really, the statements themselves, the identity statements are simpler, sure, but the whole picture of the mental is not made any simpler. And that might be the problem with Smart's argument from simplicity. So, everybody's following along? Everybody's good so far? It's raining again. Okay, good, good, good. So that's the argument from simplicity. But let's look at some explanatory arguments. Now, some philosophers claim that we should opt for identity theory because it explains certain facts which would otherwise be unexplained. And this is a good reason to accept mind-brain identity theory, right? If you have a theory that gives you the best explanation for something, you should go with that theory. That's something that we call the principle of inference to the best explanation. So here's how Kim formulates it. He says, if hypothesis H gives the best explanation... Oh, sorry, my television's talking to me. If hypothesis H gives the best explanation of phenomena in a given domain compared with other rival hypotheses like H1, H2, it could be any number of them, we may accept H as true, or at least we should prefer H over the other hypotheses. So just to use a toy example, say my best explanation is that lightning just is electrical discharge in the atmosphere. That's the best explanation. My competing hypothesis is that lightning is a result of Zeus throwing his thunderbolt, or Thor throwing his hammer, right? Well, those are interesting. Those are interesting hypotheses, to be sure. But the best explanation is probably the first hypothesis. Lightning is just electrical discharge in the atmosphere. So I'm going to go with my first hypothesis because it's the best explanation. Why is it the best explanation? It's consistent with what we know about electricity. It doesn't violate Occam's razor. Um, I don't have to posit unnecessary entities like Zeus or Thor or thunderbolts and hammers. You know, back in the day, the ancient Greeks, you know, Zeus's thunderbolt was a literal thunderbolt that Hephaestus was like making him thunderbolts, and he was grabbing them and throwing them at the mortals and stuff, right? And Thor's hammer, Mjolnir, the word Mjolnir originally meant lightning, just like Thor's name means thunder, right? So the very non-parsimonious, very cool, you know, thunderbolts and stuff, and gods and throwing hammers and thunderbolts and stuff. That's cool, but it's not a very good explanation for lightning. So I'm going to go with electrical discharge in the atmosphere. So the idea here, when we apply it to the mental, is that identity statements like pain equals or pain just is C fiber stimulation is a better explanation than rival theories like dualism, either substance dualism or property dualism, or indeed any number of other theories. So let's consider a couple versions of the explanatory argument. Explanatory argument 1. Kim says that the explanandum, that means what is to be explained. The explanatory argument 1 takes the explanandum to be psychoneural correlations, claiming that psychoneural identities give us the best explanation of psychoneural correlations. So here the claim is that these specific psychoneural identities, like the ones that we've been looking at here, or another, like consciousness equals pyramidal cell activity, explain the corresponding correlations. So pain is C fibers firing, explains pain occurs just in case C fiber stimulation occurs. Is everyone clear on that? The key is what the explanandum is. The correlations are the explanandum. If you're having trouble, just think of these analogies. You know, Clark Kent always seems to show up wherever Superman is. Clark Kent is always conveniently around, you know, some cat stuck in a tree or some baby falling from a building. And then Superman shows up and saves the cat or the baby or whatever. Well, that's just because Clark Kent is Superman. Bruce Wayne also turns up wherever Batman turns up. But you don't notice because he's Batman. You know, Walter White cooks the same crystal meth that Heisenberg does, but Skylar doesn't know that. At least not at first. You know, because Walter White is Heisenberg. Same here. Why is there a correlation between the appearance of Clark Kent and Superman or Bruce Wayne and Batman? Well, the correlation is explained by just stipulating that Superman is Clark Kent or Bruce Wayne is Batman. Well, that's begging the question. Why explain correlations between identical entities? We're explaining the correlations by positing that they are identical, by positing an identity. So we have a correlation like pain occurs just in case C fiber stimulation occurs. How do we explain that correlation? Well, pain just is C fiber stimulation. Why does Superman show up wherever Clark Kent is? Well, Clark Kent just is Superman. That's what's happening here. But we can't frame it like this. We can't explain, like, why explain the correlations between identical entities? Well, it's the identity claim that explains the correlation. That's why we're doing this. So that's explanatory argument 1. And the key for this is that the explananda are the psychoneural correlations. So again, as I've sort of said, you know, pain just is C fiber stimulation. So pain occurs just in case C fiber stimulation occurs. When it comes to other kinds of mental states, we can expand this and we can say that for every mental property or state or event M, there is a physical property, event, or state P such that M is P. So for every mental property M, there is a physical property P such that M occurs if and only if, or just in case, P occurs. Everybody's clear on this so far? So it's about 3:45, and I believe, if I'm not mistaken, I'm worried I'm going through this too fast. How do I get out of here? Yeah, we're over halfway through the slides, so I'll tell you what. Does anyone have any questions? Because I feel like I might be going a little fast here. It's because of my coffee. Oh, I'm highly caffeinated. And I think the rain, I don't know, I just love rainy days. They make me happy. Hot, sunny days, forget about it. I like those. I want rain. I want that rain. It makes me happy, and when I'm happy, I go faster. So does anyone have any questions? I will take your questions, and then we could have a break. I'm just worried I'm going so fast. Okay, well, no one seems to have any questions. So why don't we break until 4? Oh, wait, is this a question in the chat? I guess that's one way to look at it, Michael, that pain is our simple recognition that C fibers are firing rather than being caused. But is that what pain is? I mean, we don't have really good, like until neuroscience was a thing, nobody knew about C fibers, right? This is actually discussed in the modal objection, which I'm not going to talk about today. But yeah, like we've been able to meaningfully talk about pain for eons, but we've only really known what C fibers are for, I don't know, a matter of decades. So I don't know if it is that it is a recognition of that. So why don't we take a break? Let's come back at let's say 5 minutes after 4. And of course, if anybody thinks of a question while you're on break, you know, bring it with you when we come back. So we'll reconvene at 5 minutes after 4, and we will continue on with our discussion. Okay, see you all shortly.
Much, much, much later.
All right. Oh, it looks like I forgot to pause recording again. But that's fine. I'll edit out that empty space when I upload the video to YouTube later. So now that we're getting back from break, does anyone have any questions about what we've covered so far? So we've looked at different kinds of causal correlative relationships. We've talked about Occam's razor and Smart's argument from simplicity and why it might not simplify things as much as we'd like. And we've talked a little bit about one of the arguments from or arguments to the best explanation. So this is about where we left off, right? When it comes to pain, we just identify pain as C fiber stimulation, and that explains the correlation. And we can broaden this out so that for every mental state, there is a physical state that we can identify as the mental state. And that then explains why the mental state occurs when the physical state occurs. So Michael asks, identity theory sounds right, but does that mean computers, including AIs, can't have minds since they don't have brains? Or do we allow them to be defined as having brains? That's a really good question. This is actually kind of gesturing at one of the problems that identity theory faces, and that is if you have a very different kind of nervous system than a human, then psychoneural identity theory would seem to rule out being in pain, like if you're an octopus or a robot or something, right? And that is one of the problems. This is the multiple realizability objection, which we'll get to toward the end of today. But yeah, that's basically it. If you are saying that pain is C fiber stimulation, what about entities that don't have C fibers? Psychoneural identity theory would seem to rule out the possibility of them experiencing pain. But we don't want to do that. Yeah, Jack is right. Multiple realization kills this. There's also the problem that, so far we're talking about type identity theory because of I get maybe what you could characterize as weak functionalism. All of us have brains, but all of our brains are wired up a little bit differently, right? So really what we should do is think of instances of pain as, if they are identical with mental events or mental states, then they're identical with token mental states, not types of mental states. Again, we'll get to this more as we approach the end of today's material, but that's what I'll say for now. So on the first explanatory argument, if A is a good explanation, that pain is C fiber stimulation, then wonderful, wonderful. But if it's not a good explanation, then B is not a good explanation. So if pain equals C fiber stimulation is not a good explanation, then, any mental state M is really just physical state P is also not going to be a good explanation. Maybe it's not even an explanation at all. This is what Kim has to say on this. He says on page 104, if pain indeed is identical with C fiber stimulation, in what sense do they correlate with each other? For there is only one thing, whether you call it pain or C fiber stimulation, and as Smart says in the paragraph quoted earlier, you cannot correlate something with itself. For Smart, the very point of moving to the identity pain equals C fiber stimulation is to transcend and cancel the correlation. Pain occurs if and only if C fiber stimulation occurs. This is the nomological dangler to be eliminated. And further, by opting for the identity, we show that these questions have no answer, since the presupposition of the questions, namely that pain correlates with C fiber stimulation, is false. The question, why is it the case that P presupposes that P is true? When P is false, the question has no correct answer, and it cancels itself as an explanation. So why is it the case that P presupposes that P is true? The P in this case is that pain is correlated with C fiber stimulation. But there's no correlation if we're just identifying pain with C fiber stimulation. Maybe what's happening is we're getting hung up on our notion of correlation here, though. We could just say, for example, that, well, when we say correlation in this context, what we really mean is identity. But then we have questions like, why is pain, and not something like an itch, correlated with C fibers firing? And here correlated should be read as identified as C fibers firing. Identity theory doesn't help us get rid of questions like this. Why is pain, not itch, correlated with C fibers firing? Why is a certain wavelength of light correlated with red and not blue? Also, you know, if we formulate statements like pain just is C fiber stimulation, well, that's trivial. That's just that's trivial. It's like a tautology. If we place that into an argument, it doesn't tell us anything new. It doesn't do any explanatory work. Now, it's true that explanatory argument one invokes the principle of inference to the best explanation. In science, this is induction. I mean, well, again, I'm not sure if Kim has got this totally right. Argument to the best explanation is usually discussed as treated as abduction, which is a kind of induction. I'm sorry, I'm being a little pedantic there, but in science, explaining correlations aren't as straightforward as we'd like them to be, right? As I mentioned earlier, one way we can explain a correlation is to deduce our explanation from some more fundamental correlations and laws. What's an example of doing that? It can be a very broad example. But what would be an example of explaining some phenomenon by appealing to something more fundamental? Well, think of if you want to explain, you know, a chemical reaction. Like, what's a good chemical reaction? I need a chemical reaction, any chemical reaction. Dopamine is not a chemical reaction. Hydrogen and oxygen. So I mean vinegar and baking soda. Great. Yes. I mean, by appealing, so Venance is asking, what do I mean by appealing to fundamental notions? I mean, appealing to something lower level. So vinegar and baking soda, right? You put them together, they react, and they produce carbon dioxide gas, right? Why? Well, because vinegar is an acid, and baking soda is a base. And when you mix them together, a reaction occurs, and they release some gas and a little bit of heat. But okay, great. But how would I explain that more fundamentally? Well, I would have to talk about the chemical properties of acids and bases, like pH levels and so forth, right? Same with Mentos and diet soda. Yeah, like I can say like, oh, it's acids and bases, but what are acids and bases? Well, it all has to do with you know, the number of electrons that they've got and stuff like that. Right? So I can explain a chemical reaction in a more fundamental way by talking about more basic physical principles. That's one way to do it. I can also explain a correlation by showing that two correlated phenomena are collateral effects of a common cause. And an example here, well, we've already encountered one. Which of the examples we went over earlier do you think would be this? Do you think would count as an example of this? It was one of the more astronomical examples that we went over. Does anyone remember which one that was? Yeah, Deborah's right. The phases of the moon and the tides, right? The phases of the moon and the tides are all collateral effects of a common cause, namely the relative positions of the sun and the moon and the earth, right? Like if the earth is if you've got the sun in the center of the solar system and then the earth on its orbit and then the moon is on the far side of the earth, as long as it's not being occluded by the earth's shadow, which would give you a lunar eclipse, you're going to have a full moon. You're also going to have a tide, because the sun and the moon, pretend that this is the sun and this is the moon and my head is the earth. Well, the sun and the moon are both pulling on the earth and kind of stretching the oceans out like this, right? The moon is pulling harder here, less so here. So the water bulges out to the side, and that causes the tides, right? And that's just those two effects are a result of a common cause, the relative position of the bodies, the celestial bodies. What about the clock situation? Yeah, same. The clockmaker who sets all of the clocks in the morning, all of the behavior of each and every clock, all of their clocky behaviors are all a result of the common cause, which was the clockmaker synchronizing them that morning. So that is also correct, Sohaila. So good. Now, talking about argument to the best explanation, when scientists find the seemingly best explanation, they don't just stop, right? Instead, they derive new predictions from that explanation, and then they go and test those, right? The principle of inference to the best explanation, Kim says, gains credibility from its use in scientific hypothesis testing. Using it to support what is an essentially philosophical claim with no predictive implications of its own, and hence no possibility of further tests, seems at best a misapplication of the principle. It can mislead us into thinking that the choice of a position on the mind-body problem is like a quotidian testing of rival scientific hypotheses, and it's not, right? The point, the takeaway here is this: the principle of the inference to the best explanation is a good principle, but it gets its credibility from its success in the sciences. And the sciences do something a little differently than what philosophy does, right? Philosophy is what you do before you go and start doing science, right? In the words of Daniel Dennett, philosophy is what you do when you don't know what questions to ask yet. Once you know the questions and you ask those, well, then you're doing science. But prior to that, what you're doing is philosophy. So, yeah, and right here, we're not dealing with scientific hypotheses. We're dealing with metaphysical or ontological claims, fundamental conceptual claims, like about how we ought to think about the way the world is, not questions that we can go and answer in a lab. Inference to the best explanation is great if you're doing empirical science, but that's not what we're doing here, right? So choosing a position on the mind-body problem is not like testing a scientific hypothesis. And by the way, when we test scientific hypotheses, we don't verify like the logical positives sought to. So remember, we covered those in our chapter on mind and behavior. The positivists were all about verification and the intersubjective verifiability, right? The truth of a statement depends upon it reflecting the way the world is. How do we know if it does that? We have to be able to verify the statement. But science doesn't actually do that. Science falsifies or attempts to falsify. It attempts to prove its own claims wrong. And if it fails to do that, then we can take that as, okay, we can probably believe in this thing, in this theory or hypothesis, right? But of course, that's why we're always testing hypotheses, deriving new hypotheses and testing them, because if we disprove a hypothesis, well, that's good. It means we don't know what we think we knew, which means we can be more certain in our knowledge. So that's kind of the key takeaway here, I would say. How about explanatory argument 2? It says that mind-body identities enable us to explain certain facts about mentality that we would otherwise not be able to explain, like pain causing a feeling of distress. So we could say, for example, pain just is C fiber stimulation and distress just is neural state N. So we could formulate a neurophysiological explanation for why pain causes you distress. We could say, we could stipulate some neurophysiological laws such that C fiber stimulation causes neural state N, distress. Of course, there's an identity statement 1, pain equals C fiber stimulation. Another identity statement, distress equals neural state N. And since pain just is C fiber stimulation, and we've argued here that C fiber stimulation causes distress, pain causes distress, right? So it's kind of pitched at a slightly different level. But you can see what's going on here, I think. Are you all following this? We're stipulating a neurophysiological law governing C fiber stimulation causing distress. And it turns on these two identity statements. If these two identity statements are true, then we can say that pain causes distress, because pain just is C fiber stimulation, and C fiber stimulation causes stress. Everybody see how this works? Jack says, yep, good. Who does, Thomas also, good. Who does not see how it works? I mean, it's pretty straightforward, right? I think it's pretty straightforward, but if you're not sure, feel free to stop me, because I know that some of this stuff does get a little abstract. What if we used correlations instead of identities in this kind of argument? We would get something like this. C fiber stimulation causes neural state N. Yeah, Natalia, I'll go through and explain it again. So this first line just says we're stipulating some kind of neurophysiological law. We're doing what scientists want to do. We're trying to explain something in terms of a law or a law-like relation. So we want a law that says C fiber stimulation causes neural state N. What is C fiber stimulation? It's pain. That's what our identity statement 1 says. And neural state N, what is that? Well, that's distress. And now that we've defined pain and distress as C fiber stimulation and our neural state, respectively, we can conclude that pain causes distress. Right? This is just the law we want to establish. These are how we identify our terms, and this is what we can conclude. So that's really what it says. We do the same thing again. No problem. We do the same thing again here, but we use correlations instead of identities. So again, our law that we want to establish is the same. A C fiber stimulation causes neural state N. But we're not identifying, we're stipulating correlation. So pain occurs just in case C fiber stimulation occurs. Distress occurs just in case neural state N occurs. And we can conclude that pain correlates with a phenomenon that causes a phenomenon with which distress correlates. That's a mouthful. So you understand this we're doing pretty much the same thing that we were doing before. We're just using correlations instead of identity statements. Now, do the correlations do anything for us? Not really. Identity theorists say that it's the identities that are doing the explanatory work, which means that we should opt for this neurophysiological law 0. I think it's theta in the book. I just didn't want to bother with all the Greek letters. We should opt for this as opposed to this, because this one does the explanatory work. This one doesn't. It just says pain correlates with a phenomenon that causes a phenomenon that correlates with distress. We're just identifying correlations, and correlations are, I mean, we either need an identity or a causal relationship. By themselves, correlations really don't do anything for us, because anything can be correlated with anything. Nicolas Cage movies can be correlated with drownings in pools. I mean, come on. So we should opt for something like 0, but reject 1. And the point you should take away from this, which Kim raises here, is that for identity theorists, quote, these identities enable desirable psychological explanations while disabling the improper demands for explanation of psychoneural correlations. That's what identity theorists claim. Kim doesn't agree, though. He says, the trouble is that in both arguments, the identities in question do not seem to do any explanatory work and hence are not qualified to benefit from the principle of inference to the best explanation. So the identity theorist says, we don't want this, we want this. But Kim says in both cases, in this one and in this one, the identity statements are just redescribing facts about correlations, which is a similar problem we encountered earlier. What about an argument for mental causation? When I say mental causation, what I mean is that mental processes can be affected by physical processes and can also affect physical processes. So, if you get a paper cut, for example, and you're going to go like, ow, and maybe do this because your hand hurts. Say you cut yourself on your hand, right? Try and trace the causal chain backward from there. Where and how does the physical affect the mental? Well, the paper is physical, and it's physically affected your skin, which has caused a physical change in your nervous system. Those C fibers start firing all the way up into the brain, causing, it would seem, an experience of pain. You can go the other way around too, right? You experience the pain and withdraw your hand and go, ouch. So that's something mental, the experience of pain causing a physical response to that pain, right? As Kim says, the chances are that the causal chain culminating in your hand's jerky movement when traced backwards will completely bypass your pain. Or the chances are that the causal chain culminating in your hand's jerky movement when traced backward will completely bypass your pain. There will be more and more neurophysical events as you keep going back, but no mental experiences. Vinance, go ahead.
Just a quick question.
Sure.
When you brought up mental causation, my mind literally went instantly into thought process. I'm wondering, what would the explanation be for causation in terms of, the feeling of when you get hunger and and then your body starts to feel hungry or your stomach starts.
Well, I would say it's changes in your body state,
Okay.
which are it depends the way you want to cash it out, right? You can say that those are correlated with subjective feelings or hunger, or that hunger just is those changes in the body state, right?
From my perspective, I was thinking maybe the feeling came before the changes. Is that possible?
Like you feel hungry, but there's no physiological change?
Right, in an argument is you're thinking of what could I possibly eat? What can I eat? What can I eat? And then you start feeling hungry.
I guess that can happen, but I would still say that there's something physical going on there. Sometimes it could just be a matter of poor interoception, right? Like our kind of perception of our own body states. So sometimes you're a little hungry, your stomach's empty, your blood sugar's low, but you don't realize it until you start thinking about what you have to make for dinner.
That makes
right?
sense.
Yeah, sometimes that happens. That happens to me a lot where I'm kind of thinking like, what am I going to have for dinner? And I start looking at options and then I get really hungry. I'm like, wow, I'm so hungry now that I'm looking at menus or the grocery catalog or something, right? Yeah.
Thank you.
So, no problem. Michael says in argument 1, it sounds like we are saying that pain causes distress, therefore pain causes distress. but hiding the original statement in two statements. I mean, I think that's part of the issue, right? Is that we're not. Let's go back. In argument one, well, that's a ways back. Argument one is this one. Do you mean argument two? I mean, here the idea is just to try and explain the correlation by saying that there's an identity, right? By identifying pain as C fibers firing. Trying to get rid of the, oh, that one. Okay. Yeah. Yeah, I mean, Kim doesn't think that either 0 or 1 do anything for us, right? We're just restating things, re-describing facts, as he says. Sometimes you eat even though you're not hungry, yeah. But you might eat for other reasons. One of my COVID special interests, like when the pandemic was raging and there was nothing to do, I started watching those strongman competitions just for something to do. You know, the like where they do the feats of strength. Like, okay, let's see who can throw this refrigerator the farthest or something, right? And these guys, they have to eat like 10,000 calories a day. And so they're like force feeding themselves, like they're not hungry, but like they have to eat every 2 hours to stay that big. Yeah, Anthony says like Eddie Hall, the perfect example. Eddie Hall was one of those guys, and when he was competing, he ate like, I don't know, 8 to 10,000 calories per day. I don't think he eats that much anymore. He's still enormous. Like he's still like 300 pounds or whatever, but he's not as big as he was because he's not like constantly eating. Likewise with sumo wrestlers, yeah, the sumo wrestler diet is enormous, and because they're putting on all this weight to compete, so they might have to eat even when they're not hungry, right? No, Kim doesn't disagree with so Hyla's asking if Kim disagrees with neurophysiology. No, he doesn't disagree with neurophysiology or the laws. He's trying to work out what we ought to do with mental states, whether we ought to identify them with neurophysiological states or whether there's something else. That's what he's trying to do. He doesn't disagree with like what neuroscientists think about the brain. What he's trying to work out is what the mental is. Is it something over and above what happens in the brain, or is it just what happens in the brain? That's what this chapter is about. Yeah. Okay. So if you try to trace a physical causal chain backwards after getting a paper cut, chances are you could explain the entire thing without any mental states at all, which is not to say that you're not experiencing any pain or anything like that. But imagine you cut your hand, paper cut, you withdraw and go, ouch. Sure, you feel the pain, but you might even withdraw your hand before you feel the subjective sense of pain, right? In fact, this happens when we burn ourselves. It's actually a reflex that we have. You burn yourself on a hot stove, you will withdraw your hand before you really start feeling the pain. So you don't need, in that causal chain, you can have an entire causal chain without anything mental in it. It's kind of unnerving. But we want to say that the physical can affect the mental and the mental can affect the physical. Like, I have an intention to raise my arm, so I raise my arm. My intention causes me to raise my arm, right? It's mind-body causation, mental causation, which you'll remember we discussed in the first chapter. So here's a systematic version of the argument for mental causation. Mental phenomena have effects in the physical world. That's premise one. But because of the causal closure of the physical domain, the physical world is causally closed. That is, if any physical event is caused, it has a sufficient physical cause and a wholly physical causal explanation. Therefore, mental phenomena are physical phenomena. They have to be. Mental phenomena have to be physical phenomena. Otherwise, we're talking substance dualism, right? And remember, the causal closure of the physical has it that any physical event can be sufficiently explained by a physical cause. So if all the clocks are synchronized in the clock shop, a sufficient physical cause would be the shopkeeper's actions in the morning, not an invisible clock modifying leprechaun, right? So here, since mental phenomena have effects in the physical world, like I intend to raise my arm, and so I do, because of this principle, the causal closure of the physical, any physical event like the raising of my arm has to have a physical cause. So that mental phenomena must be physical. Everybody following? Kim explains it like this. He says, a qualified conclusion stands: mental events that have effects in the physical domain are physical events. The pain that causes your hand to pull back in a jerky motion and makes you cry, ouch, is a physical event. But which physical event? What better candidate is there than the brain state that is the neural correlate of pain, namely C fiber stimulation? C fiber stimulation is a necessary and sufficient condition for the occurrence of pain, and it occurs exactly at the same time as the pain. So we've got a choice. Identity theory, which is identifying mental states as physical states, or epiphenomenalism. Well, there are some subtle differences. Epiphenomenalism epiphenomenalism says that the mental supervenes on the physical, but supervenience says the mental supervenes on the physical, but epiphenomenalism says something about the causal powers that are or aren't at play. Kim discusses the differences later on in the chapter, but before we return to supervenience, what do we have here? We have identity theory, mental states just are brain states, and epiphenomenalism. There are mental states, but they're causally impotent. They're just effects. Mental states are just effects. All effects, no cause. What do we think? Is that kind of worrisome for some of you? Kind of is for me. Epiphenomenalism, that is. But then again, identity theory is problematic as well. But what do you think? What do you think? What would it mean for us? We've talked about identity theory at length. What would it mean for us if we opted for epiphenomenalism? If mental states are all effect and no cause, what would that mean? Yeah, it kind of sounds like determinism, right? As Jack says, it seems like determinism. No mental health treatment. Yeah, that's a good point, right? What we would just do? What would we do? We would just do neurology and not psychology, right? Yeah, no agency. How would things happen? Yeah, well, we would be like kind of like, well, like Huxley described, conscious automata. There's something that it's like to be us, but we are machines determined by physical processes, which is kind of unnerving, right? Because we don't feel like machines, do we? I feel like I have agency. Yeah, Jack, that's a good point. So this seems to, if we opt for epiphenomenalism, that seems to entail determinism, and determinism seems to entail that there's no moral responsibility, right? Like, say I have an intention, like if I hear a child screaming, as I often do because I live next to this elementary school, but let's say I hear a child screaming because they're, in trouble. So I form the intention to go help them, and I save them from, some kind of threat, like a rabid raccoon or something. I don't know. If my intention to help was not actually the cause of my actions, then I can't be praised for saving the child. I didn't do anything. I don't have any agency. Right? Or, if I kill someone, but I'm just some deterministic robot, how can I be held morally responsible for my actions? So it's quite unnerving. So, we could be identity theorists, where we identify mental states with brain states, or we could be epiphenomenalists, which might be a little unnerving when it comes to agency, like human agency and moral responsibility. So let's say, okay, we don't want to be epiphenomenalists. Let's be identity theorists, right? We can be identity theorists, can't we? Right? Please, can we? No, we can't. There are three forms of argument that Kim considers toward the end of the chapter here, against psychoneural identity theory. There are some epistemological arguments. There's the modal argument, and I'm not going to talk about either of these. I am going to talk about the argument for multiple realization. Kim writes that the psychoneural identity theory says that pain is C fiber excitation or stimulation. But that implies that unless an organism has C fibers, it cannot have pain. But aren't there pain-capable organisms like reptiles and mollusks with nervous systems very different from the human nervous system? I mean, there are non-human animals, forget about mammals. Mammals all have quite similar nervous systems. Because we're all cousins, we're all distant cousins, we're all on that evolutionary tree of life. But some animals are a little more distant on branches that are farther away from human beings. Like the octopus, right? Very different nervous system. If you're an octopus, you don't have a brain in your head. You have a bunch of like tiny brains that are kind of distributed throughout your entire body. And you have a hydrostatic skeleton and you can shoot ink. So, pretty badass if you ask me. But you don't have the same brain layout as a human. Maybe you don't even have C fibers, right? I'm not a marine biologist. I don't know what octopi have, but let's say they have, following Kim, something else. Maybe they have O fibers for argument's sake. We agree that they feel pain. In fact, recently, this made the news, I think, the last time I taught this course, but a number of governments, principally in the European Union, preemptively banned large-scale octopus farming, like factory farming for octopus, because of the horrible conditions they would face and the suffering that that the octopus would undergo. So they preemptively banned it. So we agree that non-human animals, even very different ones from us, can feel pain. And we can conceive of aliens with perhaps completely different physiologies, maybe even completely different organic chemistries than we have. Maybe they're not even carbon-based, right? Maybe they're silicon-based. And we could conceive that these creatures could feel pain, even though they don't have anything close to C fibers. Or maybe we could build a robot, and if we built and programmed it correctly, maybe we could make the robot feel pain. It's kind of like that clip from The Simpsons. Who's seen the classic Simpsons episodes? I'm talking seasons up until season 9. There's that one, Lisa the Skeptic. Yeah, they're the best episodes. There's one called Lisa the Skeptic, where Lisa finds this angel, and it turns out the angel was just a marketing stunt for the mall, the new mall that was being put in. But she finds the skeletal angel, and Stephen Jay Gould guest stars. And anyway, there's this the ignorant masses, the hoi polloi, rise up against science and start burning museums and whatever. And there's one scene where they set the Springfield Robotics Institute on fire, and there's a flaming robot running out of the building, exclaiming like, "Why was I programmed to feel pain?" Great episode. Yeah, and Dan Dennett has a really cool paper in his book Brainstorms called "Why You Can't Make a Computer That Feels Pain," where he argues that the reason we can't do it is because we don't have a good enough pain program. But if we did, maybe we could make a computer or a robot that felt pain. And obviously, being a computer or a robot, it would be vastly different than we are. It's made of silicon and metal and wires rather than flesh. So we would say, pain is multiply realizable. What that means is you can realize pain in a system other than the human central nervous system. So what matters, and we haven't got to functionalism just yet, but this is going to be the subject of our next lecture. And multiple realizability entails functionalism, or rather, well, really it goes both ways. But the idea here is that there are different physical means of implementing or realizing some kind of cognitive process. I like to use the example of a calculator, right? I did this before, right? This is my graphing calculator, which is one way to realize a calculator, right? But this is like a piece of hardware. But on my smartphone, I have a piece of software that's like a virtual calculator. And they're both calculators, but one is like hardware, everything's kind of hardwired into the circuit board. Another is virtual. You could have an abacus, right? Counting those beads up and doing math like that. That's also a calculator. So calculators are multiply realizable. If you're a functionalist, so are mental states, because what matters is how the thing functions, not what it's made of. So we're going to examine this next time. Functionalism as we know it today is due primarily to a guy named Hilary Putnam. And he was building on the work of Alan Turing. Putnam, again, I don't really want to get ahead of myself, but what Putnam does is he builds on Turing's formalization of computation as algorithmic information processing, which Turing does with an imaginary machine called a Turing machine. And Putnam comes along and says, well, hey, our minds are basically Turing machines. And that's kind of the essence of his machine functionalism. We're going to focus on this. This is why I'm focusing on this argument as opposed to the epistemological arguments and the modal arguments. It's because of functionalism that type physicalism went the way of the dinosaur. So again, if you're a functionalist, mental states are functional states. They're not identical with physical states because they can be realized in a number of different ways. Multiple realizability means that mental states cannot be identified with physical states. Now, type physicalism, though, doesn't work. Type physicalism says that each type of mental state is a type of brain state. So pain is C fibers firing. The problem is my brain's not wired up exactly the same as yours. There are non-human animals with differently organized nervous systems and different brains, but we agree that they can experience pain. So instead, token identity statements might help us if we want to save identity theorists. So you have to go for token identity theory or token physicalism. So let's be clear on the difference between types and tokens, right? What is a type and what is a token? Who wants to tell me? Jack, go ahead.
Tokens would be like particular instances of events or something, and then types would just be like kinds or like general, I guess, types.
Yeah.
I don't like using that word to explain it, but I think it's kind of the best way of explaining it.
Yeah, I mean, I use the whole particulars versus universals way to make sense of it. That's what Aristotle would say. Yeah, and Deborah in the chat, a type is identical configuration and tokens would be instances of it. Yeah. So like car is a type of vehicle, but each and every car parked on the street outside of my apartment is a token of that type of vehicle. Right? So what type physicalism says is that every type of mental state just is a type of brain state, but that doesn't work. But token identity theory says that this tokening of pain is an example of a type of mental state. So my C fibers firing and your C fibers firing are two different tokens of the same type of mental state. Well, I don't think you have to get quite as radically subjective as Nagel does, like about not knowing what it's like to be a bat. I mean, animals engage in pain behavior, which, as we saw in the chapter on behaviorism, it's really hard to explain pain behavior without resorting to mental states. Otherwise, you end up treating non-human animals as beast machines, the way Descartes did. We might not know what pain is like for an octopus or a bat, but we agree that they are in something that functionally is pain, right? And also given the evolutionary history we share with other creatures on this planet, it seems like a pretty safe assumption, right, to assume that animals can experience pain. Moral on slide 25. Let's go back. What moral? So Hyla, what do you mean there when you say on 24? I don't know what you mean. Modal judgment. Um 20 okay, 25. Oh, we're no, you don't need to know. Oh, you mean the modal argument. No. You don't need to know about that. I'm not going to test you on that. Nor the epistemological arguments. I'm not going to test you on that. If one of these counter arguments is going to be on the test, it'll be about multiple realizability. Yeah, multiple realizability will almost certainly be on the quiz because we're going to talk about it next time when we talk about functionalism. Yeah, so yeah, don't worry about the modal argument. The modal argument just has to do with I'll just say this: it's more Kripke. It's like Kripke and Putnam. You know, water is H2O versus XYZ. It's that whole thing. Don't worry about it. I really don't want to get into the weeds with that one. Basically, it's just a matter of whether pain is C fibers firing. It's an identity statement, but is it a necessary identity statement or a contingent identity statement? And the argument is that it's a contingent identity statement because it could have been otherwise. It could have been that we could live in another world where C fibers firing doesn't equal pain; it equals itches, right? Things could have been otherwise. Can I repeat why multiple realization is tied to functionalism? Yeah, functionalism emphasizes how a system functions rather than what it's made of. And that means that you can implement the same system using different physical means. So an identity theorist would say, in order to have a mind, you need to have a brain. But a functionalist would say, well, sure, you can have a mind implemented in a brain, But you could also have a mind implemented in a very sophisticated computer, right? So, and that's what the calculator example is about, right? Like a calculator calculates. I can implement it physically, like print it on a circuit board, like this calculator. I can implement it virtually, like the calculator on my phone. Or I could have a completely different kind of calculator, like an abacus, for example. And all of those are calculators. What makes them a calculator is not what they're made out of, it's what they do. And that's functionalism and multiple realizability. So these examples here of pain being realized in other non-human animals or in alien life forms or in robots mean that pain is multiply realizable. So all identity statements like pain equals C fiber stimulation are necessarily false. Because what matters is not physical implementation. What matters is functional relations within the system. So again, there's no hope for type physicalism, maybe token physicalism, where again, my C fibers firing and your C fibers firing are two tokens of the same type of mental state. But it's not like there's one monolithic type of C fiber stimulation that we all have. It just doesn't work that way. So if you want to remain an identity theorist, you can be a token physicalist, but type physicalism doesn't work for reasons that Putnam made very, very clear. So type physicalism, another drawback is that it's very reductive, right? It reduces kinds of mental states to kinds of physical states, and so it eliminates mental states. But token physicalism says that the pain I have right now is a neural event of the type of being in pain, but octopuses, aliens, and robots might have different pain tokens, right? So Kim explains that the most widely accepted form of physicalism today combines substance physicalism with property dualism. All concrete individual things in this world are physical, but complex systems can and sometimes do exhibit properties that are not reducible to lower level physical properties. Among these irreducible properties are most notably psychological properties, including those investigated by the psychological and cognitive sciences. And of these kinds of thinkers, we have supervenience physicalists. They'd say the physical is what is fundamental, but there's a close and indispensable relationship between physical states and mental states, right? Wherever you find physical state P, you will find mental state M. But then there are realization physicalists. They say that non-reducible mental states are nonetheless physically realized or implemented. All non-reductive physicalists are also mental realists. So if you're a physicalist, but not in that reductive way, in the way of eliminativism or type physicalism, you're a mental realist, which means you think that mental states are real. They really exist. Michael says, if we said that C fiber stimulation is pain for humans and had other definitions for other minds, wouldn't that work for identity theory? Well, that's essentially what token identity theory or token physicalism does. It just says, for humans, in my case, my C fibers firing, that's a token of a type of mental state, pain. But for an octopus or for a robot, it's going to be something else. It might be O fibers or their pain chip is activated, right? Or like in Return of the Jedi, that's another one. Remember in Return of the Jedi when R2-D2 and C-3PO go to Jabba's palace and Luke is like, here, you can have them. Because again, Luke Skywalker is a slave owner. They get owned, now they're owned by Jabba the Hutt and they're being assorted into their new roles. And there's this poor robot who's being flipped upside down and burned. So yeah, that's kind of unnerving. The robots, I mean, they're persons. The robots in Star Wars are persons. They can feel pain. And they are They're just property. Star Wars needs to deal with that. Anyway, what do non-reductive physicalists say about the mind-body problem? Well, if they're property dualists, they would say that, well, you know, there are mental properties, and those are a different kind of thing. But it's not a substance, it's just properties. And we can't reduce those properties down to just physical properties. The mind-body problem would still be a problem. Like David Chalmers is a property dualist. And he's famous for articulating the hard problem, which is another way of it's another way of it's kind of a redescription of the mind-body problem. How can we understand subjective consciousness with the tools of objective science, right? Realization physicalists say non-reducible mental states are physically realized. So there are mental states that we can't reduce to physical states, but nonetheless, they are realized or implemented via those physical states. That's what they would say. Does that make sense? All right. Again, we're going to get into functionalism a lot more on Wednesday. So, you know, if it's not 100% clear yet, don't worry. But here are some claims that non-reductive physicalists make. They subscribe to substance physicalism. Space-time world consists exclusively of bits of matter and their aggregates. The mental is irreducible. So mental properties aren't reducible to physical properties. They either opt for supervenience or realization. So either mental properties supervene on physical properties, or mental properties, when they are realized by physical properties. Mental causal efficacy. Mental properties are causally efficacious. Mental events are sometimes causes of other events, both physical and mental. An epiphenomenalist would not believe in this, but don't worry about that. So those are some claims that non-reductive physicalists make, token physicalists, or property dualists, perhaps, or heck, even some functionalists. All right, that's all I have for today. So that means we're finished just a teeny tiny little bit early, which is fine with me because I'm hungry. I imagine you all are too. Nothing like doing philosophy to work up an appetite. Well, so I want to say thanks for tuning in. The grades for quiz number 1, once again, they are available. Go check them out. We don't have a quiz this week. Instead, it's the essay proposal. So no quiz this week, because last week I didn't teach you anything other than how to write an essay. So write your essay proposals. Make sure you get in touch with me if you have any questions. I'm going to try and have the grades for quiz 2 done a little sooner than I did quiz 1. I'm feeling a lot better, so I should be able to do it. Yeah, Michael, if we said activating circuit, 1465 by 23 is pain for R2D2, yeah, token physicalism. Maybe you could understand it that way. I would say it's fun. I would rather be a functionalist. I'm a functionalist. But I think you could couch it within the terms of like token physicalism if you wanted to. Because this activation of this circuit would just be a token of a type of mental state that is pain. So yeah, that works. All right. See you all on Wednesday. Okay. Thanks, everybody.